We'll be talking about co-design and how we implement that in our work and practice in the assistive technology space. We're from TAD and Solve in New South Wales and Victoria, and we make up part of TAD Australia. We're non-for-profit organisations, and we rely on a group of volunteers who are a mix of both practicing and retired engineers, programmers, designers, or people with a trades background, and they work in teams with people with disabilities and therapists like yourselves to modify or create assistive technology. Now, this might happen where ideas for technology doesn't exist on the market, or where existing technology just doesn't work for any particular reason, which you might have come across before with your clients. Working in teams, co-design is something we implement very naturally, and it's all about involving the user in the design process with a group of professionals like occupational therapists to come up with a solution together. This makes sense because the user will provide the most powerful input in understanding what's going to work with their lived experience. It's all about moving away from a consultation type relationship and focusing on engagement and having choice and control through a participatory design. At its core, co-design is driven by the user's goal and is an iterative process. That means there's lots of prototyping of parts for the user to trial, so we can constantly evaluate what's working and so we can make adjustments for it to work in the best way. This creates a dynamic where everyone can learn from each other and come up with the best solution for the user to be happy, achieve their goal, but also be empowered through the process. Now we talk about how we've done this through some case studies. This is Patrick. He's a 5-year-old boy and his family describe him as very sociable and he loves to play with other kids. He was diagnosed with acute flaccid myelitis following an infection that he had. This is a condition that affects the spinal cord, and for Patrick, it resulted in limited ability to control his upper right limb. He came to TAD to have a bike modified so he could cycle safely and independently. So this was his goal. And we had the family, an occupational therapist, physiotherapist, and 2 volunteers involved to develop a solution together. And with Patrick's lived experience and background, the family knew that he would require a support for his right hand on the handlebars to be able to sit up comfortably, balance and control steering. And they knew this support needed to be lightweight for him to control predominantly with one hand, and that overall the design needed to be seamless so he could feel that he would fit in with his friends and other kids. From a therapy point of view, you'll see a sketch of the initial idea we came up with following assessment with the family. We identified what a safe position might be for Patrick on the support, which was with his palm facing upwards as he had best control here. He had some slight active elbow flexion. We also identified for him to be independent, he needed to easily position and remove his hand from the support, and for safety reasons needed removal to be quick. And we also noticed the support couldn't simply be attached to the handlebars, as that meant if he was turning, his arm would come in and impede his posture. So it needed to move independently and separately to the handlebars. And then we had our 2 TAD volunteers involved who have backgrounds in biomedical and mechanical engineering, and they came up with ideas for the build to help us meet all these requirements. And this was a really big process in terms of coming up with ideas together, thinking about function, thinking about appearance, creating prototypes for Patrick to trial, and then making adjustments based on feedback and observations. So you'll see the initial concept that everyone agreed on. You'll see Patrick's arm in a fabric glove to provide padding against a lightweight 3D printed support based on measurements of his arm. A magnet that could be easily detached on a ball joint for it to move independently to the handlebars, and this is all connected via some more 3D printed clamps and parts to the handlebars. We did multiple trials to ensure everything worked okay. This included prototyping the 3D printed support for Patrick to test the fit and feel. When this worked, we did trials to set up positioning on the bike, how easy it was for Patrick to put his hand on and off, and how easy it was for him to steer the bike. And through these trials and evaluations, we ended up with these changes. You'll see what's different is that there's holes in the support for straps to be woven through, as Patrick needed more stability on there. Originally, we used Velcro straps for him to do up easily with one hand, but found that the magnet was really strong. So we used elastic straps with some stretch as a second option for him to pull and withdraw his hand easily. The magnet attachment provided a swivel, so no ball joint was required, and positioning-wise, we didn't need that extension arm for Patrick to sit upright comfortably. This is the final product, and everyone was involved through the entire design process. in terms of thinking about function, appearance, and making sure that it worked easily. I learned what was important to the family, which was about it being really easy for Patrick and also for him to be like other kids and fit in. I also learned about the innovations and technology available from the volunteers to be able to do this. And without the family's input, we may have used something really heavy or bulky, which would have been challenging for him physically, but also emotionally. So with the family's input, we were able to get this very well thought through design, and without them, we wouldn't have been able to have all the finer adjustments that led to what you see here. And now I'll pass over to Melissa to share her case study.
Thank you, Betty. Hello everyone, my name is Melissa, the Occupational Therapist from Solve Disability Solutions. I'm going to present to you my case study. Let me introduce you to this remarkable young gentleman. His name is Chris. Chris is a 28-year-old gentleman with autism spectrum disorder and obesity. He will spend all day sitting in front of the computer and not doing any physical activities. So Chris contacted Solve one day as he would like to be motivated to do exercises to improve his overall health. So his carer reports that they have tried various exercises such as swimming, gym. However, none of these exercises actually motivates him to be physically active. So one of the goals that Chris identified is to return to outdoor cycling. He reports that the last time he rode a bike was about 20 years ago. He hasn't been doing bike riding because of his weight, and he has lack of confidence doing this activity. Chris also expressed that he is one of the most enthusiastic fan of Hey Hey It's Saturday. Does anyone remember this childhood show? Yes, it's a polka dot show. So Chris has all passion about all things relating to Hey Hey It's Saturday, in particular the carousel machine. So myself and 9 technical volunteers get together at Chris's place to obtain his needs and the design of the polka dot carousel as an exercise machine design. So one of the technical volunteers has also contacted the producer of the polka dot show to find out about the structural details behind the polka dot carousel machine. The truth is, the original carousel machine has a person inside turning the handwheel of the carousel. Unfortunately, NDIS won't fund a human motor. Hence, our technical volunteers split into 3 groups, one to build the carousel, one to build the penny farthing bike, and the other groups to build the solar panel. The carousel has a solar panel that generates energy using the Hall effect principles to spin the carousel when Chris pedals. So in order to operate the motion of the carousel with the duck spinning as a visual feedback, Chris must pedal very hard to work on his muscles and energy. So this exercise will also build up his endurance and prepare him for outdoor cycling. Chris is making extensive use of the carousel exercise equipment, and he also contacted Solve and told us that he's getting a Freedom Wheels bike to expand his cycling adventures. I feel very proud of him getting out and about, socializing in the community. Solve and TED are part of the national network of TED Australia, and there is one of us in 7 states and territories. TED Australia works closely with universities such as ACU, RMIT, Swinburne, and Tom Melbourne to provide educational experience to engineers, designers, to work with people with disability, and in every stage of innovative ecosystem. The main goal of the co-design is actually fairly simple. We want to get the people with disability to involve in every stage and to give people choice and control in their assistive technology. From my experience working at Solve, the nitty-gritty details about how to build a customized assistive technology is actually quite complex. Therefore, it is very important to get the AT users' feedback in every stage. In conclusion, there are 3 key points of co-design to be considered. Firstly, the awareness. It is my job and your job to help to spread awareness that every person with a disability is a unique individual in terms of their lived experience, their accessibility, and their preference in assistive technology. Secondly, empowerment. TED Australia empowers technical volunteers to practice their expertise in real-life settings and to find value in the lived experience of people with a disability. Thirdly, engagement. We have a sustainable model to engage the communities in co-designing a custom AT for people with disability. I hope you'll be part of this innovative movement too. Thank you so much for your time today. For more information, please visit tedaustralia.org.au. Stay safe, everyone.